I'm looking over the problems, and I'm just like, I didn't do anything because I didn't really know what to do. I was like, I don't know what I'm doing here.
All right, so these ones are to state whether it's odd, even, or neither. And it says to support graphically, confirm algebraically. We're just doing the algebraically part. So 48, g of x is equal to x cubed. And so basically, let me see if I can find it in the notes here since, you know. No, not right now. Well, probably not at all today. Where is it? Is it not in the notes? Oh, there it is. Okay. So it's under the section about symmetry, but when we're talking about, so if we're plugging in negative x into the equation, and then whatever comes out, that tells us if it's even, odd, or neither. So if you plug in a negative x and the whole function comes out positive, or I like to say sometimes opposite of whatever it started as, because it could be negative to start with, and so it needs to come out like positive or whatever. If it comes out opposite in the end, then it's even. If it's odd, then it's going to come out with the whole function being negative. So if you plug in a negative x, it's going to come out to be negative if it started positive. So, okay. And some of them, it's just going to make sense. Like with this one, you could probably tell me without me doing absolutely anything if this is even, odd, or neither. Yes. So, we plug in g of negative x. So we get negative x cubed, which is negative x cubed, and I'm writing it this way so that you can see it compared to the notes. So now this whole thing became negative, so this is going to be odd. Um, 50 g of x is equal to 3 over 1 plus x squared. So we plug in negative x, so g of negative x is equal to 3 over 1 plus negative x squared. So that's going to become 3 over 1 plus x squared. So the whole thing became positive, okay? Or like, yeah, the whole thing became positive, like stayed the same as what it was to begin with. And so this is going to be even.
Squared on top of the x.
Because it was just negative x squared. So I squared the negative and I squared the x.
Oh, okay.
I'm not trying to solve anything with these. I'm literally just trying to see if the negative goes away or stays, basically. 52. F of x is equal to x cubed plus 0.04x squared plus 3. All right, so f of negative x is equal to negative x cubed plus 0.04 times negative x squared plus 3. So the negative x cubed is what? Yep, negative x cubed, so it's staying that way. Then 0.04 times negative x squared becomes, yep, so plus 0.04 x squared, and then plus 3. So, looking at this one, okay, the first x, the x cubed, is negative now. It was positive to begin with in the original. The 0.04 x squared was positive to begin with, and it's still positive, and then the plus 3, we don't really care about that part. So, because these are different, they either needed to both be positive, or they needed to both be negative for this to be either even or either even or odd. So because they're different, it's neither. So if they had both become negative, it would have been odd. If they had both become positive, it would have been even. Okay, so because it was 1 and 1, it ends up being neither. One more of those. H of x is equal to 1 over x. So try this one on your own for a second. This one should be a slightly easier one. But. What do we get? Everybody agree? Okay.
I was really sad. I was scared I got it wrong. I was like, there's no way.
Everybody looks like they're half asleep. So.
Maybe we are.
So we plugged in the negative, came out the whole thing negative, so that is odd.
I'm just a big fan of the imagination. We're not really here.
The nice thing about this book is that they're pretty clearly even, odd, or neither. The calculus book isn't quite so nice when it does it because it'll do it to where it's like opposite of what it started as. Because like if the whole thing started negative and it's odd, it's going to be actually become positive. So it can get really confusing. But don't worry about that because this book is a lot nicer than that and doesn't give you super crazy ones.
So if
Like
the
that.
whole thing starts out as one thing and then it becomes
Basically, if it
opposite,
becomes the other.
like the entire thing has to become the other.
If it stays the same, it's even. If it changes, it's odd, basically.
So what about that plus 3?
That part doesn't really matter.
So
Because
even
that
if
didn't
that's
really,
positive-
nothing really happened with that.
So if it stayed positive and everything else ended up negative, all
It would be
things
based
that-
on the x's, yeah.
Okay.
But typically a problem like that, because it's going to be some kind of quadratic, or not quadratic, but it's, well, yeah, anyways. Some kind of polynomial, that's the word I'm looking for. They're typically going to have an odd and an even variable, which is going to end up causing a problem. So, now you can always graph it and see, and you're basically counting the number of humps in the graph, and then that kind of tells you too. If the graph ends with like it both going like the same way, like either so like a parabola, they're both going up this way, that's going to be even. If it does something like this, but they're going opposite ways, it's odd. So if you graphed it on your calculator, you could check it that way. So, math dance. my pose for Dancing with the Stars. Math pose.
It's like the walk like an Egyptian thing.
But sideways.
Even sideways. Walk like
I'm
a
X cubed.
parabola.
I'm X squared now. Okay. Use a method of your choice to find all horizontal and vertical asymptotes of the function. So 56 q of x is equal to x minus 1 over x.
Why Q?
I was literally just thinking the same thing. I don't know. I mean, Q's a great letter and all, but like,
Not for math.
no.
It just doesn't look right.
All right, vertical asymptotes occur where?
Like they're kind of vertical. You know, they
On the line.
Y.
Well, okay,
Axis.
Not on a graph, sorry.
Oh.
In a problem, how do you determine where the vertical asymptotes are?
I have no idea. I forgot.
What would cause a problem with this?
The X thingy.
Okay, yeah, so you just told me the vertical asymptote. Where the denominator is 0. Okay, so we take the denominator and set it equal to 0. And so that is our vertical asymptote. Normally we have to, write it. But the thing to remember with the asymptotes is that they have to be written as an equation of a line. Okay, if you just write vertical asymptote 0, I'm going to say, wrong. Okay, it's got to be an equation of a line. When you graph them, you put dotted lines where they are, if you happen to be graphing them. So,
Wait, how did we find out that it's 0?
where the denominator is 0. Vertical asymptotes occur where the denominator is 0.
Oh, okay.
Basically, whatever causes a problem with the domain is what we're worried about for that. But vertical asymptotes are only going to occur when you have, like, a quotient.
So anytime if it's asking us to find the vertical asymptote and it's like the x is in the denominator, it's always going to be 0?
Yeah, so, like, the one where, well, hold on, we need to finish. Let me finish this one with the horizontal, and then I'll show you one that's different, because this one is just an x in the bottom, so you don't have to do anything.
Yeah.
And there will be times, too, that the denominator doesn't have something that causes a problem. Because it could be possible that the denominator, there's no way for it to be 0. Because whatever you plug in would just give you a number that is either positive or negative. It would never end up being 0. So that is possible, too, which we'll have an example of that as well. So horizontal asymptotes, okay, they occur. We have BOBO, which is bigger on the bottom, okay, which would mean that, like, we have, like, x over x squared, okay, that would be that y equals 0. We have Bosco, which is both the same, okay, which is the situation we have here, x over x. We use the coefficient. Now, the coefficient means the number that's in front of the x's, okay, whatever your biggest x term is. So if this was -1 plus x over x, we still are looking at the x and the x. We're looking at the biggest x term, or whatever the variable is on the top and the bottom. So in this case, there's a 1 in front of here and a 1 in front of here, so my horizontal asymptote is at y equals 1. That's Bosco, and then Botno, Bobo, Bosco, Botno. Botno is bigger on top, so if there was like x squared over x, no, there's not. There's not a horizontal asymptote there.
Oh, I'm getting it now. It's settling in my brain now.
All right, 58. This one is going to be a little bit weird. We kind of just have to know something about this type of function. Oh, we get q of x again. Look at us go. 58. Q of x is equal to 1.5 raised to the x. So there's unfortunately not just like a fancy way to know what this is. Let me see how I defined. So sometimes with horizontal asymptotes, we have to actually look at the end behavior of the function to know what's happening. So the other ones, all the ones that are quotients, Bobo, Botno, Bosco, works. But when it's something like this, we can't just look at like x over x and see what the number is. So what we have to do is we have to look at end behavior. So basically, I think last year we did a little bit with end behavior, and I said I'm really just introducing this to you. I care about what happens as x gets really, really small or really, really big. And so basically, if you looked at a graph like this is an exponential function. So an exponential function is going to look something like this. So this graph, as x goes to positive infinity, it's going up to infinity, basically. It's getting there really fast. But as x goes toward negative infinity, it's going to keep getting closer and closer and closer and closer to 0, but it's never going to hit 0. Okay, because there's a horizontal asymptote at y equals 0. So one like that, if you were to get it, let's say you didn't know what that looked like, that's one where you could throw it in the calculator into y equals and then use that trace function and just keep arrowing to the left. Or if it had a negative exponent, it would be going the other way. It'd be going down, and you could arrow to the right and just see and make sure you know. But an exponential function, unless it's got a like +3 over here or something, it's always going to be y equals 0. So if it had that, it would just be shifted up, and then wherever the shift is, up or down, that's where the asymptote's going to be. So in this case, this is technically like +0. It hasn't shifted, so it's at 0. If it was +3, it would be at 3. If it was at -2, it'd be at -2. So, but I think that's the only one in the book that's not a quotient. Yeah, it is. So you don't have to worry about that one that much. 60, p of x is equal to 4 over x squared plus 1. So vertical asymptote, I'm checking where the denominator is equal to 0. So I'm going to set x squared plus 1 equal to 0. So subtract 1, so x squared is equal to -1. Square root x is equal to plus or minus the square root of -1. But what's the problem with that?
Imaginary numbers.
It's an imaginary number, so I can't possibly have an imaginary number getting plugged in for x. It's not possible. So this one is going to have no vertical asymptote. So I just write vertical asymptote none. So basically, because this one was x squared, there's no value, and this was +1, there's no value that I can plug in here that's going to give me a -1 that's going to cancel that out, basically. That's going to cause that to be 0. So then, horizontal asymptote, okay? So I've got Bobo, which is bigger on bottom, right? That's the situation I'm dealing with. So I've got no x's on top, and I've got an x squared on the bottom. So bigger on bottom, y equals 0. So horizontal asymptotes at y equals 0.
So how would we know that like the bottom's bigger if we didn't know x? Or is it just saying like?
Because it's saying that there's no x's on top, and I have basically 2 x's on the bottom.
Okay.
So anytime if you have a variable on the bottom and none on the top, it's always going to be bigger on bottom.
Okay.
And if you ever have, like, let's just say, like, x squared over 3, that's bigger on top. So no, there's not. So there's none. And then if it's, you know, x cubed plus 2, or, well, x cubed plus 2x squared plus 3 over, and then let's say they did it like 3x squared plus 4x cubed, and that's it. The temptation is to do this and look at x cubed over 3x squared. But you can't do that. You've got to look at the biggest term, top and bottom. So I care about this and this. These are both the same, so we use the coefficient top over bottom, which would be 1 over 4 for that. Does that help a little bit? Okay.
For the horizontal asymptote for y equals 0, is that just another one where it's like it's because it's 0 because it's in the denominator?
No, so it's Bobo. So Bobo is bigger on bottom. Bigger on bottom, y equals 0.
Okay.
The first part tells you where it's
Where
bigger,
it's going.
or like both the same.
Yeah.
Then CO is the coefficient for Bosco.
Okay. That's right.
It'll.
Okay.
I promise it will start to make more sense. It's,
Yeah.
People are usually like, huh?
Yeah, because I'm thinking like we just use the coefficients, so why wouldn't y equal 1 or y equal like 2 or something? Yeah. Okay, that makes sense. I actually mean it this time. It does make sense.
Okay. All right, let's do another one. H of x is equal to 2x minus 4 over x squared minus 4. So vertical asymptote, I care about where the denominator is 0. So x squared minus 4 equals 0. Now you can think about this two ways. This is a difference of squares, but you can also just move the 4 over and take the square root, which is what I'm going to do. So x squared is equal to 4. Take the square root of both sides. X equals what? Plus or minus 2. So my vertical asymptotes, and notice it's plural, I have 2 of them this time. You can have more than one. I have a vertical asymptote at x is equal to 2, and I also have one at x equals negative 2. This is a situation where you have to split them. Don't just tell me x equals plus or minus 2. That's not a line. Okay. And it doesn't ever seem to matter how many times I say that. I always have somebody in the class not write it as an equation of a line. So that's why I'm saying it like obnoxiously over and over again, because I want you to know it has to be written as an equation of a line. Unless it's none, it's an equation of a line.
I'm going to overthink it on the test again this time, and I'm going to write it as just 2.
All right, horizontal asymptote. So I've got an x over x squared. So what situation is this?
But no.
That would be bigger on top.
Bobo.
Okay, it's bigger on bottom because x squared is bigger than x. So bigger on bottom, so horizontal asymptote is?
0. Y equals 0.
Y equals 0.
Like I said, overthought.
Now, if this had been flipped, just so that we have an example of this, so I'm just going to modify 62 and do h of x is equal to x squared minus 4 over 2x minus 4. So I've just flipped it. Vertical asymptote would be set the denominator equal to 0. 2x minus 4 equals 0. 2x equals 4. X equals 2. So I would have a vertical asymptote at x equals 2. Now, Riley, what situation do I have?
But no.
But no, bigger on top. So botno.
I don't know that one.
BOTNO.
No.
No, there's not. So there are none. I was like, bot no.
Like, n equals 0? What are we serving other letters in here?
All right, any questions on this stuff that we did today? At the moment. I'm not saying you won't have questions later, but at the moment, are there any questions? Where did I stop on the problems that I gave you yesterday? What was the last one I gave you?
39.
Okay. Then we need to do one thing once I turn this off. I was like, hold on a second, because I have to show you the ones on the calculator. 41, 43, 49, 51, 53, 55, and 61.